that okay? I think so. Okay, homework. So which one is first? The capacitors, isn't it? Is that Amanda? It is Amanda. Come on in. You have a good sleep? Yes? That's good. No coffee?
No.
Right, what's the first question? You have the questions, guys?
Yeah. Capacitor?
Yeah.
100 millifarad capacitor was allowed fully charged.
That's a microfarad.
Micro.
Is it micro mu?
Yeah.
Okay. So the first question then.
100 mF.
M is milli.
It's not M. It's that symbol.
Is it a mu?
Is that?
Oh, just show me. Just show me. Yes, it's micro. Yes. Yeah.
But this one is milli.
What? Can't be different. You took the second. No, that's the second homework.
Oh, yeah.
We're doing this one first. Right, so, Hareen, it's 100 micro,
Yes.
and what else are you told?
Capacitor is connected in series to 150 microfarad
Yeah,
capacitor.
so these are connected together, okay. And then what?
And then charged by using a cell. What is the total combined capacitance?
Easy peasy. 1 over C is 1 over 100 plus 1 over 150. So if I multiply by 1.5, I'll guess, what's that? 2.5 over, I'm tired. I'm so tired. I can work it out, I'm smart. Okay, so that is 5 over 300, which is 1 over 60. So the C equals 60 microfarads. Trust me. Ham sandwich?
Every day.
Every day. No breakfast for you?
I'm eating during the math class.
You had math class at 9?
Yes.
Yes, okay. Oh, were you in math class, Amanda?
Yeah.
Oh, you sure? Never mind. Number 2. What's number 2?
50
Yeah.
microfarad
Yeah.
capacitor connecting parallel to the 200 microfarad.
What's the total capacitance?
A battery of 6 volts used to charge between the capacitors of what is the total charge held.
Okay. 6 volts, you say?
Yes.
Come on, Amanda.
Okay.
It's not breakfast time.
Okay.
Now, what's the total capacitance here? It would be what?
Q equals to...
The capacitance.
C
Equals...
C1 plus
Yeah, 250 micro. And you have the formula C equals Q over V. Yeah, so Q equals CV equals 250 times 10 minus 6 times 6. What's that? 1500 times 10 minus 6, isn't it? So let me see. I need to divide this by, well, this would be 1.5 times 10 to the 3, isn't it? Yeah. 10. No, I wasn't finished. So it's 1.5 millicoulombs. So far, so good?
Yeah.
Great.
Yeah, what is a millicoulomb?
This multiplies together to make 10 to the minus 3. Okay, what's number 3? Grace, you can give it to me this time.
100 micro.
This one?
Yes.
Yeah, micro, yeah. Farhad. Yes.
Capacitor is connected in parallel to the 200
You just said it 1 minute ago. 200 microfarads, yes.
Capacitors are then connected to a 300. Look at again. Micro.
Yes, okay.
These combined capacitors are connected to a 12-volt battery and are allowed to charge up. How much charge is held by each capacitor and hence from the total charge held by all capacitors?
Great. Was the last question the total charge as well, or each charge?
Total.
Okay, so this is the first one where you have to get each charge. Yeah, okay. So what I would do first is break this into two. The first one and the second one. And then this is 12 volts. So because this is in parallel, this would be 100, 200 added together. So this is a 300 micro and this is 300 micro. So you have Q, now, you know that if I add these together, I get 1 over C equals 1 over 300 plus 1 over 300. This will be 2 over 300, which is 1 over 150. So together, it makes 150 micro. Okay. Q equals CV. Q total is 150 micro 12. Now what's that? (150) times micro times 12. That's 1.8 millicoulombs. But if the total is 1.8 milli, when they're in series, each of them must be 1.8 milli. Okay, so if I go back to the picture at the start, this is 1.8 milli. Are these both 1.8? No, these ones are different, but the total should be 1.8. So we need to work out the charge here. Now, what's really nice, I made this nice for you, because these are both the same, it means the voltages here are both the same. What's the voltages here? No. Must be 6 and 6 to make the 12. So,
in a series is equal.
but the voltage?
Yeah.
No, in parallel they're equal.
Okay.
Yeah. So what's the voltage here? 6. So what's the voltage on each of these? 6. So you can say for the top one, run out of space, Q top, that equals the C on the top times the voltage on the top. So that would be 6C. And the bottom one would also be 6C, but the C is different. We'll call it C1, C2. Right, so finally Q, this is C1, C2. Q top will be 6. Now what was the first capacitance? 100? No, 100 micro?
Yeah.
Right, so on the top you get 0.6 millicoulombs, and then on the bottom, well, the total should be 1.8, so I think this should be 1.2 milli. Let's check it. How much is the bottom? Is it 200?
Yes.
1.2 milli. So there are the first two, and then the third one, C3, is that. So there are my three answers. 0.6 milli, 1.2 milli, and 1.8 milli. Total 1.8 milli. How many more questions are there?
2 more.
Two more?
Mhm.
Great, okay. Right. When you're ready, let me know. Did you get this one, Grace? Good job. So you must like electricity. Okay. Patrick, can you give me number 4?
Yeah. It's a 150 micro.
150?
Yeah.
Yep. Micro farads, yeah.
Capacitor holds a charge of 150 millicoulomb, and
Yeah.
this capacitor is then allowed to discharge. What is the voltage of the
Okay.
resultant current?
So you have a capacitor. Its capacitance is 150 microfarads, and it has a charge on it, and the charge is 150 millicoulombs. So Q equals, or C equals Q over V. So V equals Q over C. So that would be 150 times 10 to the minus 3 over 150 times 10 to the minus 6. So that is 1000 volts. Do you want the voltage?
Yeah. What is the capacitor is allowed to discharge?
So by the way, guys, if you drew the graph here, what I'm saying is in this one, it starts off with 1000 volts and then it decreases, as you know from yesterday. Okay, that's the last one. Amanda, have you got the last question?
Yeah.
Yeah.
A 200 microfarad capacitor, and it's placed in parallel with 300
Farad
capacitor.
In
And
parallel, you said?
Yeah,
Yeah.
parallel. And the voltage is 5 volts.
5 volts.
Yeah. And the the battery is removed and the circle is closed, and ask the question is, what will the voltage being the resulting current?
Can I see the question, please? Yeah. A 200 microfarad capacitor is placed in parallel with a 300 microcapacitor and charged by 5 volts. They are allowed to fully charge. The battery is removed and the circuit closed. The small capacitor is flipped around. Okay, you missed that part, and an important part. Right, can I go down and do this one?
Okay.
So, okay. So, firstly what happens is we put the two capacitors together. And I said we use 5 volts. So what's the total capacitance here?
It's 500.
500. No.
Yeah, the total would be 500 micro. I would like to calculate the charge on each of them actually. So we have Q equals CV. Now we know the C's and we know the V. What's the V on each of these?
5.
Has to be 5. So if I do the small one on the top, 200 micro by 5. So this is 1 millicoulomb, and then the one at the bottom, 300 micro multiply 5. This is, no surprise, 1.5 millicoulomb. So this is the start, okay?
Hey, which one is the top one?
I'm putting the smaller one on the top, okay? So this one is on the top, and this one is on the bottom. So far okay? Okay, continue. So then what I do next is actually let me draw the current in. So let's imagine the current is going around this way. So then what I do is I remove the battery. And then what I do is I take this capacitor and flip it, turn it around. So then what happens to the current? It comes out the other side. So instead of going to the right, let me just delete that. The current will want to go out to the left. Yeah? Now, this is good because it means now the current goes around in a circuit like this. Yeah? Now, what was my question? What's the voltage, is it? Maybe somebody can try and answer. Do you think it will stay like 1 and 1.5?
No.
Will they both decrease, both increase, stay the same?
They will both equal each other.
No, they can't increase because there's no battery, there's no cell. So there's no more charge that can get in. It can't decrease because where's the resistor? You know, there's no resistor. Huh? I don't know. No. True, but no. Well, the total charge will still be there's still 1 coulomb and 1.5. So they're not going to turn into 0 because there's no resistor to do any work. But they won't stay the same. They won't stay the same. They should change. My question is, how will they change?
One will increase, one will decrease.
One will increase and one will decrease. Because remember, this problem is like this problem. Isn't that really the same thing? Series or parallel? Series. So in fact, this is actually in series, not parallel anymore. And when they're in series, what do you know about the charge? It has to be the same. So 1 and 1.5 is no good. What do you think it will change to?
1.25, 1.5.
I think 1.25 and 1.25. They'll balance like this. Yeah. So this will change into it wants to go to 1.25 millicoulombs. Then it's balanced and everything is good. So let's calculate the voltage. Do we know the Q? Do we know the Q? Yes. Do we know the total capacitance? We need to work it out. Let's do that. 1 over C equals 1 over 200 plus 1 over 300. So C equals 120 microfarads. So I know the Q and the C, so I can get the V. V equals Q over C, which is 1.25 milli over 120 micro. So I get a voltage of 10.4 volts. That was a difficult question. That was a difficult question, especially if you didn't read the part about it being flipped. Did anybody get this? No. But this is a difficult one. This has been on the exam, but it was on the exam once, and that was a long time ago. So I think the good news is it's not going to be as difficult as this, but this will be an example of something difficult on the exam with capacitors. But usually the capacitor questions are more like this one with maybe 3 capacitors. Or sometimes, if you're lucky, only 2 capacitors, if you're very lucky. Okay, will we do the next homework now? Yep, okay.